Students, we will discuss about datum systems in this session. A component in space can move in all the three directions x, y, z, and it can rotate about all the three axes x, y, z. So any component in space is enjoying 6 degrees of freedom. It can move along the x direction. Let us say this is the component. It is free to move along the x direction. So that is the translation along x-axis. It is free to move along the y-axis. There is translation along y-axis. Okay. It can move up and down. That is the translation along z-axis. These are the three translation degrees of freedom. Apart from these three, we have got other three rotational degree of freedom. This component is free to rotate about the x-axis. So that is the rotation about x-axis. Similarly, you can rotate this component about the y-axis. You can rotate it. Similarly, you can rotate the component about the z-axis, about the vertical axis. So here we have treated the vertical axis as the z-axis. So these are the 6 degrees of freedom that a component can enjoy. 3 translational degrees of freedom and 3 rotational degrees of freedom. I have shown a door hinge on this paper. This door hinge is one of the mechanical assembly where you have to constrain the required degrees of freedom for the proper functioning of this door hinge. So this door hinge has 3 parts: the leaf 1, the leaf 2, and a pin at the center. So for the proper functioning of this door hinge, the 5 degrees of freedom of one leaf with reference to the other leaf has to be constrained or arrested. I will just draw the isometric view of this leaf 1, leaf 2, and the pin. Let me take this as the x-axis, this as the y-axis, and the vertical axis is the z-axis. On leaf 1, we have got a surface shown as datum plane 2, and on leaf 2, we have got a corresponding surface that is datum plane 1. For the proper functioning of this hinge, I have said that we have to arrest all the 5 degrees of freedom except for the rotation about the z-axis. Let us see how each and every dyf is getting arrested in this example. When datum plane 1 is assembling with datum plane 2. So datum plane 1 is this surface on the bottom of the cylindrical member. Datum plane 2 is on the other leaf, corresponding surface on the other leaf. When both are assembled together, one is in contact with the other, how many degrees of freedom is arrested among the 6 dyf? Let us discuss one by one. Translation along x. So can you move this leaf over this leaf without losing contact? So when you place one over the other, surface 1 over the other, surface 2, can you move this surface 1 along the x direction without losing contact? So it can be moved. So it is not constrained. So the translation along x is not arrested, not constrained. Okay. On placing the datum plane 1 over the datum plane 2, okay, the translation along x is not arrested. Similarly, the translation along y is also not arrested, because upon keeping the surface 1 over surface 2, still, okay, this leaf can be moved along the y-axis, okay, without losing contact between the two surfaces. So it is not arrested. So translation along y is not arrested. What about translation along z direction? So once you try to move this leaf, okay, in the vertical direction, that is the z axis, the contact between the surface 1 and surface 2 is getting lost. So you cannot move the leaf 2, okay, without losing contact between the two surfaces. So translation along z is arrested upon placing datum plane 1 over the datum plane 2. So translation along z is arrested. Now coming to the rotational degrees of freedom. On placing the datum plane 1 over datum plane 2, can you rotate the leaf 2, okay, along z x-axis? So if you try to rotate this surface along x-axis, the contact between the two surfaces is getting lost. So you cannot rotate without losing contact. So it is really arrested. So the rotation about x-axis is arrested on placing datum plane 1 over the datum plane 2. Similarly, the rotation about y-axis is also arrested, okay, on placing datum plane 1 over the datum plane 2. That is also really arrested. But if you try to rotate the leaf 2 over leaf 1 on placing datum plane 1 and datum plane 2 together, still you can be able to rotate without losing contact between the two surfaces. So the rotation is not arrested on placing datum plane 1 over the datum plane 2. Now, okay, when you place one datum plane over the other datum plane, among the 6 DYF, 3 are arrested, the 3 are not arrested. But for the proper functioning of the hinge assembly, we need to arrest 5 DYF. So the remaining 2 DYF has to be arrested. For that, we have a pin, okay, that is getting assembled into the hole. So we have to place these two leaves together. Then, okay, in the hole we have to insert the pin. So that forms the door hinge assembly. So the pin assembling with the holes, that results in arresting of some more degrees of freedom. So when the pin is placed in the hole, okay, on putting together, then, okay, the translation along x is arrested. Okay, on putting the pin in the hole, okay, you cannot move the, okay, leaf B, okay, in the x direction. Okay, it is getting locked. Similarly, you cannot move the leaf B in the y direction. It is getting locked. So when you introduce a pin assembling with the hole, the translation along x and translation along y are getting arrested. The remaining 1 degree of freedom, which is not yet arrested, is rotation about x, rotation about z axis, which is really needed not to be arrested for the proper functioning of the door as a hinge. Okay. Because when you fix this leaf A over the frame of the door, okay, you will be fixing the leaf B, okay, on the door. Then the door has to be moved, okay, rotated about the, okay, hinge point. So we need to really, okay, keep the rotation about that direction not arrested for the proper functioning of the door hinge assembly. Let us discuss about one more example. This is the electrical bulb holder. This is the electrical bulb. When this electrical bulb is mounted over the holder, all the 6 DYF of the bulb with reference to the bulb holder have to be arrested for the proper functioning of this assembly. Let us see how each and every DYF of this bulb is getting arrested. So when you design a bulb holder and a bulb, we have to incorporate the necessary features on this part as well as on this part, so that all the 6 degrees of freedom of one member over the other member are properly arrested. So what are the features that are present in this bulb, and what are the features that are present in this bulb holder that are helping in arresting each and every DYF of this bulb? We have to discuss. When you insert this bulb into the holder, the contact point on this bulb is assembling with a contact points on the bulb holder. So there are 2 spring-loaded pins on the bulb holder. The end surface of this pin are in contact with these 2 surfaces of the bulb. So a datum plane on the bulb is assembling with a datum plane on the bulb holder. The 3 DYF, that are getting arrested are translation along Z, rotation about X, rotation about Y. The 3 DYF that are not arrested are translation along X, translation along Y, and rotation about Z. In order to arrest some more DYF, we have cap assembling with body on the bulb holder. So this cap is a cylindrical member. On the body we have got a cylindrical hole. So when this cap is assembling with the hole on the bulb holder, how many DYF are getting arrested? So cap assembling with the body, translation along X is arrested, translation along Y is arrested. The remaining one, which is not yet to be arrested, is rotation about X. So we have to write here. So still the rotation about Z is not yet arrested. In order to arrest the lost DYF also, we have introduced a pin and a slot. There are 2 pins on the electrical bulb and a slot, a pair of slot is provided on the bulb holder. So you have to insert the bulb into the bulb holder so that the pin is going through the slot, and you have to lock by rotating the bulb little bit. So this pin is assembling with the hole or a slot on the bulb holder. So pin assembling with slot. So when the pin is assembling with the slot, the rotation about the z-axis is also getting arrested. So the z-axis here is the vertical axis. So z-axis, we can treat this as x-axis and this as y-axis. So this electrical bulb and bulb holder assembly is designed such a way that it has got the necessary elements on both the bulb and bulb holder to arrest all the 6 DYF, so that the bulb is constrained with respect to all the 6 DYF in reference to the bulb holder. A tool holder and a tool insert is shown in this figure. On the tool holder, we have a group of 3 datum plane. The base D, the perpendicular surface E, another perpendicular surface F. So these are the group of 3 mutually perpendicular datum plane on one member. On the tool insert, we have 3 mutually perpendicular datum plane. The bottom surface of the insert is A, and C is perpendicular to A, and B is also perpendicular to A, and A, B, C are the another group of 3 mutually perpendicular datum plane. So this group of 3 datum plane is assembled with this group of 3 datum plane to arrest all the 6 DYF. So the orthographic view of the tool holder is shown here. The orthographic view of the tool insert is shown here. Necessary geometric tolerances have to be added on this drawing. For example, the flatness tolerance on the surface D has to be introduced. Similarly, the surface E and surface F are to be perpendicular to D. The necessary perpendicularity tolerance have to be included in the drawing. Similarly, on the tool insert, the bottom surface, you have to invoke the flatness tolerance, and C and B are perpendicular to A. So we have to invoke the perpendicularity tolerance for the surface C and surface B. The necessary geometry tolerances have to be added in this.